Okay, welcome back to the deep dive. So today we're going to pull back the curtain a bit on something that's, well, really fundamental if you're interacting with large language models. We're talking about those sort of invisible dials, the ones that shape the actual output you get back. Have you ever been like really impressed by an LLM's creativity 1 minute and then maybe frustrated in the next because it just keeps repeating itself? Or, I don't know, maybe you just wish to get to the point a little faster.
Yeah, well, if so, you're definitely not alone. I think many of you listening are familiar with how LLMs work generally, but today we're giving you the keys, really, to exert true control over what they produce. Our mission is to demystify these things called LLM hyperparameters. They're the hidden settings influencing randomness, creativity, diversity, even just how wordy the AI gets. Think of this as your shortcut to becoming, well, much better at steering AI generation. Okay, let's unpack this. Absolutely. And what's fascinating here, I think, is that we're diving into the how. Not what the model learned during training, which is a whole other topic, but how it actually applies that knowledge when it's generating text right in front of you.
Right.
And understanding these controls isn't just, a technical detail. It's really crucial if you want to use AI effectively. They're basically the levers you pull, right, to turn a general text machine into something tuned for your specific need.
Like crafting a poem versus drafting a legal summary.
Exactly. Completely different requirements, needing different settings.
That's a really powerful way to frame it. You're not just prompting, you're directing. And I guess the first dial most people think about, or maybe should think about, is temperature. People often call it the creativity dial. And that seems pretty fitting. It directly controls the randomness, right?
The randomness in the model's next token prediction. Because that's what it's doing, fundamentally. It's like a super sophisticated guessing machine for the next word or, part of a word, a token.
And it has probabilities for all the options.
It does. It generates this huge probability list for every possible next token. Temperature then kind of scales those probabilities.
Okay, so how does scaling work? If you dial it down low.
If you set it really low, like close to 0, it massively exaggerates the difference between the most likely token and everything else. So the model almost always picks the absolute top probability option. It becomes very deterministic.
Very predictable.
Exactly. But if you dial it up, say closer to 1,
which some models let you do, maybe even a bit higher sometimes.
right, then it flattens that probability distribution. It makes even the less probable tokens look more appealing, more likely to be chosen.
So it gets more random, more willing to take a chance on an unusual word.
Precisely. And this simple number, usually between 0 and 1, has really profound effects. Imagine you're, say, brainstorming with an AI. You want unexpected ideas.
So you'd set a higher temperature, closer to 1.
You would. You're encouraging it to explore those less likely, sometimes more out there token choices. This gives you much more diverse, often creative, sometimes really surprising outputs. It's great for, like, imaginative stories or pushing concepts.
But there's a downside, right?
Oh, definitely. The risk increases. You're more likely to get text that, well, wanders off topic, becomes incoherent, or even includes factual errors, those hallucinations people talk about.
Because it's deviating so much from its core training.
Exactly. It's like telling an artist, don't just paint what's usually there, paint something totally new. Sometimes it works, sometimes it doesn't.
Okay, so high temp is high risk, potentially high creative reward. What about the other end, low temp?
Right. So conversely, if you need extreme precision, think factual summaries, legal documents, maybe generating code.
Things where accuracy is paramount.
Exactly. You'd go for a lower temperature, much closer to 0. Then the model sticks very closely to its most probable predictions. The output becomes focused, predictable, much more reliable.
Less exciting, maybe, but dependable.
You're trading off that inventiveness for accuracy and consistency. So, yeah, for that abstract poem, you might crank it up. For the legal brief, dial it way, way down.
Got it. It's about choosing your creative risk level for the task.
Come on.
Okay, that makes a lot of sense. Temperature is like the overall mood or risk tolerance. But what if you want maybe a more nuanced control over diversity? Like you want creativity, but you also want it to stay, I don't know, statistically grounded.
Now you're talking about TopP, also called top sampling, or sometimes nucleus sampling.
Okay, another control for diversity. How's it different?
It is, but it works differently in a way that people often describe as more refined or dynamic.
Okay.
So while temperature just rescales all the probabilities globally, TopP acts more like a filter based on cumulative probability.
Cumulative probability, how does that work?
Okay, step by step. First, same as before, the LLM generates the full probability list for all possible next tokens.
Right, the big list of words and likelihoods.
Exactly. Then you set a TopP threshold value, let's say 0.9, so 90%. The model then looks at its probability list, sorted from most likely downwards. It starts selecting tokens from the top.
The most probable ones first.
Yes, and it keeps adding them to a kind of temporary candidate pool until the sum of their probabilities just exceeds your threshold, the 0.9 in this case.
I see. So it gathers just enough top words to reach that 90% cumulative probability.
Precisely. It forms a nucleus of the most likely options that collectively meet that probability mass. And then here's the key part. Instead of just picking the single top word or rescaling everything like temperature, it randomly samples one token, but only from within that selected nucleus set.
Okay, so it narrows the field first, based on probability mass, and then introduces randomness within that smaller high probability group.
You got it. So if you set TopP to, say, 0.5, as one of our sources mentioned.
It would only consider the very top tokens until their combined probability hit 50%.
Right. A much smaller, more conservative nucleus than if you set it to 0.9.
Which would include a wider range of possibilities.
Exactly. But crucially, even at 0.9, it's still drawing only from the most statistically significant options that make up that 90%. It avoids the really long tail, super improbable stuff automatically.
So it's like temperature might let the model pick a really weird spice from the back of the cupboard just because you turn the dial up.
Haha, yeah, that's one way to put it.
Whereas TopP is like saying, okay, only consider the spices that make up 90% of what chefs normally use for this dish, then pick one randomly from that group.
That's a pretty good analogy, actually. It ensures diversity, but within a realm that's statistically sensible based on the model's training. Controlled creativity, perhaps.
Controlled creativity, I like that. So higher TopP means more diverse, but still likely coherent results.
Generally, yes. More diversity by considering a wider nucleus. Lower TopP means more focused, predictable output because the nucleus is smaller, restricting choices to only the very most likely tokens.
What about using temperature and TopP together? Can you do that?
You can, but it gets complicated. Often, people recommend picking one as your primary diversity control.
Why is that?
Well, they interact in complex ways. A very low TopP might completely override a high temperature, for instance.
The nucleus is so small, the temperature scaling doesn't matter much.
Potentially, yeah. Or they could create unpredictable effects. A common approach is maybe a high temperature for really wild brainstorming, but using TopP, like 0.8 or 0.9, when you want creative options that are still likely to be relevant and make sense.
So TopP provides a kind of safety net for creativity.
That's a great way to think about it. It allows exploration without completely falling off the statistical cliff.
Okay, this is adding layers to how you can steer these things.
Yeah.
Very cool. Now let's shift gears a bit. Beyond creativity and diversity, there's another common and honestly sometimes really annoying issue. Repetition.
Ah, yes, the broken record problem.
Exactly. When the AI just gets stuck saying the same word or phrase over and over and over, it can make the output totally useless.
It really can. And it often happens because the model is very good at predicting the immediate next word based on local context, but it doesn't always have a perfect memory of everything it just said further back in the generation.
So it just keeps picking the same high probability word if it fits locally.
Often, yes. That's where the penalty parameters come in. Let's start with frequency penalty.
Okay, frequency penalty, what does it do?
It directly tackles that repetition problem. It works by reducing the probability of a token being generated if that same token has already appeared multiple times in the text generated so far.
So it penalizes words based on how frequently they've shown up already.
Exactly. The more a word has been used, the less likely it becomes to be used again. Its main job is to stop the model getting stuck in those repetitive loops.
How does adjusting it change things, like a higher penalty?
A higher frequency penalty strongly discourages repetition. It pushes the model to find synonyms, to rephrase, to use a more diverse vocabulary, makes the text less redundant.
And a lower penalty.
A lower frequency penalty means the model is more tolerant of repetition. It allows words to reappear more easily.
Which isn't always bad, right? Sometimes repetition is needed.
Absolutely. Think about emphasis, or maybe certain stylistic choices in poetry or technical writing, where consistent terminology is key. So it's a trade-off, again, finding the balance between forcing variety and allowing necessary repetition.
I remember trying to get an AI to write a product description once, and it just kept saying this innovative product features
Yeah.
and then listing the same feature slightly reworded. It was maddening.
Classic frequency issue. Our source material had a good example with a story about friends.
Yeah.
With a low frequency penalty, like 0.3, the model generated text like they went to the park, they played at the park, saw friends at the park, very repetitive.
Right.
But when they reran the same prompt with the frequency penalty cranked up to 1.1.
And avoided repeating park so much.
Significantly. It forced the model to describe the scene using different words. It makes a huge difference to readability and just sounding less robotic.
That friends example really makes it click. It's like telling someone, okay, you've said park 3 times, find another word.
Pretty much.
Now, you mentioned penalty parameters, plural. There's another one that sounds similar, presence penalty. How is that different?
No.
This is where it gets subtle, right?
It is subtle, but it's a really important distinction for fine-tuning. Okay, so frequency penalty looks at how many times a word has appeared.
Right, the count matters.
Presence penalty, on the other hand, is simpler, more like a binary switch. It reduces the probability of a token being generated again if it has appeared in the text at all, even just once.
Oh, so it doesn't care how often it appeared, just whether it appeared.
Exactly. Once a word is present, the penalty applies to discourage it from appearing again. It cares about presence, not frequency count.
Okay, wait. Let me try to summarize that. Higher frequency penalty, less repetition based on word count, more variety overall.
Correct.
Higher presence penalty, less repetition of any word that's already shown up, even once.
You've got it. The source material summarized it well. Higher penalties generally mean less repetition. Lower penalties allow more. The difference is what triggers the penalty count versus just being there.
So why have both? When would you use one over the other?
Great question. It depends on your goal. If you just want to generally encourage more varied language and stop the model from overusing common words, frequency penalty is often a good choice.
Like nudging it towards synonyms.
Right. But if you want to strongly discourage the model from reintroducing specific concepts or keywords once they've been mentioned at all, maybe you're generating unique survey questions or writing something where repeating a specific term changes the meaning. Presence penalty gives you that stricter control.
Okay, that makes sense. Frequency for general variety, presence for stricter avoidance of any recurrence.
Exactly. It gives you that finer level of control over the vocabulary texture.
This is incredibly useful. Feels like we're really getting under the hood now. One last control that seems basic but maybe overlooked is max new tokens. What's the deal with that?
Max new tokens or sometimes max length? Yeah, it seems simple, but it's critical. It does exactly what it says. It sets the maximum number of tokens the LLM is allowed to generate in its response.
So it's just a hard stop.
A hard stop. Remember, tokens aren't always full words. They can be parts of words. So if, say, a token is roughly 0.75 words on average for English.
Setting max new tokens to 100 gives you about 75 words max.
Roughly, yes. It's an upper limit on the length of the output.
Why is that so important? Seems obvious you wouldn't want it writing forever.
Well, that's the first reason. It prevents runaway generation. Without it, some models might just keep rambling on, generating loads of text, potentially irrelevant stuff.
Okay, sensible. What else?
Cost. If you're using an API, you usually pay per token generated and sometimes per token in the prompt. Setting a reasonable max new tokens is crucial for managing your budget.
Good point. Stocks unexpected bills.
Definitely. And thirdly, it's about focus and conciseness. If you ask for a short summary, you don't want a 5-page essay.
Right. You use it to match the output length to the task.
Precisely. Need a quick answer? Set it low. Need a detailed explanation? Set it higher. It's the ultimate guardrail against the AI being too verbose or too brief for your needs.
Wow. Okay. What an incredible deep dive this has been. We've really journeyed through these crucial controls. We started with temperature, that main creativity dial, balancing randomness and predictability, low for reliable, high for imaginative. Then we had TopP, that more refined diversity control, using cumulative probability, getting creativity, but keeping it statistically grounded. Controlled creativity, as you said.
That's right.
Then we tackled the repetition problem with frequency penalty, which cares about how often words appear.
And presence penalty, which cares just if they've appeared at all.
Yeah.
Subtle but important difference.
Definitely. And finally, max new tokens, the essential length limiter for cost, control, and conciseness. I feel like anyone listening now has a much, much clearer picture of how these models actually build their sentences and, more importantly, how you can influence that process. So what does this all mean? What's the big takeaway for someone using or building with AI?
I think the biggest takeaway is agency. You have far more control than just writing a good prompt. These parameters are powerful tools, and maybe a thought to leave people with is, think about the extremes. Considering how finely you can tune these settings, when would you really want maximum, almost unhinged creativity? What applications thrive on that?
Like experimental art generators, maybe, or crazy brainstorming.
Perhaps. And conversely, where is absolute rigid precision paramount? Where does an AI need to be highly constrained, super predictable?
Compliance checks, data extraction, code generation, maybe.
Exactly. Thinking about those use cases helps solidify why these controls matter, which applications benefit most from tight constraints, and which ones need that freedom, even the risk of nonsense, to potentially discover something new.
That's a great framing. Understanding the tools helps you choose the right one for the job or even invent new jobs for them.
Precisely. The more you understand and, crucially, experiment with these controls, the more mastery you gain. It unlocks so much potential in how you can leverage this technology.